introduce you a way to evaluate your model in prediction, and it is called cross-validation. So what is how to evaluate your model in prediction? In statistics, we fit a lot of models every day. Models are really important. We use models to explain our random variables, and we use models to do prediction. And models are important, but what is more important is how to evaluate it. Because with the same data set, we can have different models. And evaluating the models and choosing the best one from them is very important. And basically, we have two ways to do that. One is sampling new data. That means we have a model and we don't know whether it is reliable. We can create some new data and just apply the model to the data and to see whether they are right or wrong. And this is the most common way, and it's very easy to come up with. And the second way is cross-validation, which is we are going to talk about today. And what is cross-validation? Because here we don't create new data. We don't have new data to test our model. We may think that maybe we can divide our original data into two parts. And one part is training set, and the other part is validation set, which we can also call it as test set. And we use the training set to fit our model, to create the model. And we use the validation set to test whether the model is correct or not. And here is the algorithm. First step, we randomly divide our data into k-folds. Here, we set the k equals to 10. And this is our original data. And we just divide it into 10 folds. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And like this. And step 2, we treat first fold, just the yellow part. We treat this as our tested data, and the other 9 folds together are our training set. And then we fit our model with the training set, and that's what the step 3 says. And then we apply the model to the tested data and calculate the model accuracy. And here the validation accuracy is 93%. And I think validation accuracy is easy to understand to you guys. For example, we have a model which describes the relationship between the age of a kid and the height of a kid. And we may do some prediction with our model. And whether if our prediction is right, we may say, oh, this time it's right. And we do a lot of this kind of tests and to calculate the accuracy of the outcomes. And step 4, we just repeat step 1 and step 3 for each fold. That means in the second round, we take the second fold as our validation set and just do the same thing again. And then we continue this procedure until the last fold. And we can calculate the validation accuracy each time. And the final accuracy is the average of all the accuracies we have already got. And here we have a final accuracy which can help us to evaluate our model. Definitely, the higher the final accuracy is, the better our model is. And it has advantages and disadvantages.
You need to finish. Feedback.
She had said an example. I think if you put your examples in your PowerPoint, it will be better to understand this whole thing.
Yeah, I think sometimes it's maybe better when you do some eye contact with us without looking the PowerPoint.
Yeah, and one thing, this is tough people when people run out of time, what do you need to do when you run out of time?
Sorry, I'm running out of time.
Well, or you could just say, we'll finish this next week.
Yeah.
Okay.
Yeah.
But I promise you, the worst thing you can do is rush through.
Yeah.
Because your students, you know, if they're undergrads, they just want out of the room. And if you are rushing, you're gonna talk faster, and then they don't care and they don't understand. So, good, thank you.